This is the final video, this is video 7 of the paper 2 for the maths mock. Now the next two topics that we're going to look at are both topics that we have not yet done within maths. The first one is all to do with speed time graphs. So here is here's a graph showing the journey of a snowboarder. Up the side we have got the speed of this snowboarder, and on the bottom time. So we are looking at how fast and slow a snowboarder is going over time. So clearly he's speeding up, eventually gets to a point of continuing at the same speed, and then very quickly slows down within the space of these 2 minutes. Now, as I said, this is a topic we've not yet done, but I can very quickly show you how to do this, and it might be relevant for the exam. If you have a speed time graph, in order to work out the distance, all you need to do is work out a rough estimate of the area of the space underneath the graph. Now, without going into a lot of detail of counting the number of squares and working out an exact value, what we can do to estimate is actually use a rough shape that looks similar to what we've got on the graph. For this one, I am actually going to draw a triangle. The way I'm going to do that, obviously with a ruler in the real exam, is take the highest point of that graph as the highest point of my triangle. I am then going to draw a straight line that goes down to the end of the graph, and another straight line that goes to the start of the graph. So whilst this triangle here is not the exact same as the area underneath the graph, it is not far off. So there's some little bits where we've overestimated, but then some bits where we have underestimated. Remember to find the area of this triangle, which is going to be very similar to the one that you need to do in the exam. All we need to do is half times base times height. So in this example, we would have to do half times base, simply goes from 0 to 120, so that is 120 long, times by the height. Now the height of the highest point of this triangle, if we read off the graph, comes out as 9.4. So if you type that into your calculator, what you get is 564. So we would say that this is an estimate for the distance travelled. Now the speed was in meters per second, therefore the distance travelled would have to use meters, so we would say that it's 564 meters. Even if you can only do elements of this question, or even if you can only put the units, if you notice it's a 4-mark question, so there are a lot of marks available for doing some very small basic bits with it. The final question we're going to look at is this. Again, another topic we have not looked at. This is all to do with looking at more complex formulae and more complex modelling of equations. Clearly Mr. Smith has made this one. So we have got that there is a formula where B is the value of a collection and Y is the number of years. So obviously certain things that you collect appreciate or depreciate in value over time. This one is that kind of example. So we've got this little formula that we are given where it says Q and P are constants. That simply means Q and P are numbers that we need to find out what they are. We have got two scenarios, so this is actually a little bit like proportion, when we had to substitute values in to find what some of the missing numbers were. If we start with this very first one, the value of the collection when new was £1,450. So if here I substitute in B is the value of the collection, so I put for the first one 1,450 equals Q, we don't know what that is yet, multiplied by P, we don't know what that is, to the power of minus Y. If Y is the age of the collection, so the number of years old it is, at new that would mean that y is equal to 0. Now if you remember back from the index laws topic, that means we've got 1450 equals q times, and p to the power of 0, much like anything, any number to the power of 0 is equal to 1. So that'll give us q times 1. Well, q times 1 is just q, so here we have found that 1450 equals q. So we've found one of the values. What we can now do is work on this second set of details. So this time it says that the value is £1,200. So I'll take our formula again and replace the letter B this time with 1,200 equals Q, which we have now found out is 1,450, times P, we don't know what this one is yet, to the power of minus Y. If it is 2 years old, that would mean minus 2. What I now want to do is make P the subject of this formula. So at this point, I would need to try and divide by 1,450. So if I do that to both sides, I get 1,200 over 1,450 is equal to P to the power of minus 2. Now at this point, it actually does get a little bit confusing. So if this is the bit that you don't understand with the question, that's fine. A negative power, remember, means that we do 1 over it. Or in the case of a fraction, we would have to flip it upside down. So we would get from this that P squared is equal to 1,450 divided by 1,200. In order to find P, I would need to do the square root of that. So if I take my calculator and do 1,450 divided by 1,200 and then square root that value, what we get is a value of 1.0, let's type in the correct numbers first, gives us a value of 1.099. Now if this element is difficult to you, understandable, this is grade 9. If you can do at least some of these parts, you will be achieving 2, maybe 3 marks on this question, and it is at grade 9.